A telephone, or phone, is a telecommunications device that permits two or more users to conduct a conversation when they are too far apart to be heard directly. A telephone converts sound, typically and most efficiently the human voice, into electronic signals suitable for transmission via cables or other transmission media over long distances, and replays such signals simultaneously in audible form to its user. In 1876, Scottish emigrant Alexander Graham Bell was the first to be granted a United States patent for a device that produced clearly intelligible replication of the human voice. This instrument was further developed by many others. The telephone was the first device in history that enabled people to talk directly with each other across large distances. Telephones rapidly became indispensable to businesses, government, and households, and are today some of the most widely used small appliances. The essential elements of a telephone are a microphone to speak into and an earphone which reproduces the voice in a distant location. In addition, most telephones contain a ringer which produces a sound to announce an incoming telephone call, and a dial or keypad used to enter a telephone number when initiating a call to another telephone. Until approximately the 1970s, most telephones used a rotary dial, which was superseded by the modern DTMF push-button dial, first introduced to the public by AT&T in 1963. The receiver and transmitter are usually built into a handset which is held up to the ear and mouth during conversation. The dial may be located either on the handset, or on a base unit to which the handset is connected. The transmitter converts the sound waves to electrical signals which are sent through the telephone network to the receiving phone. The receiving telephone converts the signals into audible sound in the receiver, or sometimes a loudspeaker. Telephones permit duplex communication, meaning they allow the people on both ends to talk simultaneously. The first telephones were directly connected to each other from one customer's office or residence to another customer's location. Being impractical beyond just a few customers, these systems were quickly replaced by manually operated centrally located switchboards. This gave rise to landline telephone service, in which each telephone is connected by a pair of dedicated wires to a local central office switching system, which developed into fully automated systems starting in the early 1900s. As greater mobility was desired for commerce and convenience, various radio systems were developed for transmission between mobile customer stations on ships and automobiles from the 1930s. By the mid-1900s, radio systems evolved into various cellular topologies until the first handheld mobile phone was introduced for personal service starting in 1973 by Motorola. By the late 1970s, several mobile telephone networks operated around the world. In 1983, the Advanced Mobile Phone System was launched in the US, and in other countries soon after, and offered a standardized technology providing portability for users within a region far beyond the personal residence or office location. These analog cellular systems evolved into digital networks with better security, greater capacity, better regional coverage, and lower cost. The public switched telephone network, with its hierarchical system of many switching centers, interconnects telephones around the world for communication with each other. With the standardized international numbering system, E164, each telephone line has an identifying telephone number that may be called from any authorized telephone on the network. Although originally designed for simple voice communications, convergence has enabled most modern cell phones to have many additional capabilities. They may be able to record spoken messages, send and receive text messages, take and display photographs or video, play music or games, surf the internet, do road navigation, or immerse the user in virtual reality. Since 1999, the trend for mobile phones is smartphones that integrate all mobile communication and computing needs. Basic principles. A traditional landline telephone system, also known as plain old telephone service, commonly carries both control and audio signals on the same twisted pair of insulated wires, the telephone line. The control and signaling equipment consists of three components: the ringer, the hook switch, and a dial. The ringer, or beeper, light or other device, alerts the user to incoming calls. The hook switch signals to the central office that the user has picked up the handset to either answer a call or initiate a call. A dial, if present, is used by the subscriber to transmit a telephone number to the central office when initiating a call. Until the 1960s, dials used almost exclusively the rotary technology, which was replaced by dual-tone multi-frequency signaling with push-button telephones. A major expensive wireline telephone service is the outside wire plant. Telephones transmit both the incoming and outgoing speech signals on a single pair of wires. A twisted pair line rejects electromagnetic interference and crosstalk better than a single wire or an untwisted pair. The strong outgoing speech signal from the microphone does not overpower the weaker incoming speaker signal with side tone because a hybrid coil and other components compensate the imbalance. The junction box arrests lightning and adjusts the line's resistance to maximize the signal power for the line length. Telephones have similar adjustments for inside line lengths. The line voltages are negative compared to earth to reduce galvanic corrosion. Negative voltage attracts positive metal ions toward the wires. Details of operation. The landline telephone contains a switch hook and an alerting device, usually a ringer, that remains connected to the phone line whenever the phone is on hook, is open, and other components which are connected when the phone is off hook. The off-hook components include a transmitter, a receiver, and other circuits for dialing, filtering, and amplification. A calling party wishing to speak to another party will pick up the telephone's handset, thereby operating a lever which closes the switch hook, which powers the telephone by connecting the transmitter, receiver, and related audio components to the line. The off-hook circuitry has a low resistance which causes a direct current, which comes down the line from the telephone exchange. The exchange detects this current, attaches a digit receiver circuit to the line, and sends a dial tone to indicate readiness. On a modern push-button telephone, the caller then presses the number keys to send the telephone number of the called party. The keys control a tone generator circuit that makes ETMF tones that the exchange receives. A rotary dial telephone uses pulse dialing, sending electrical pulses that the exchange can count to get the telephone number. If the called party's line is available, the exchange sends an intermittent ringing signal in North America and UK and 60 volts in Germany, to alert the called party to an incoming call. If the called party's line is in use, the exchange returns a busy signal to the calling party. However, if the called party's line is in use but has call waiting installed, the exchange sends an intermittent audible tone to the called party to indicate an incoming call. The ringer of a telephone is connected to the line through a capacitor, which blocks direct current but passes the alternating current of the ringing signal. The telephone draws no current when it is on hook, while a DC voltage is continually applied to the line. Exchange circuitry can send an AC current down the line to activate the ringer and announce an incoming call. When there is no automatic exchange, telephones have hand-cranked magnetists to generate a ringing voltage back to the exchange or any other telephone on the same line. When a landline telephone is inactive, the circuitry at the telephone exchange detects the absence of direct current to indicate that the line is not in use. When a party initiates a call to this line, the exchange sends the ringing signal. When the called party picks up the handset, they activate a double-circuit switch hook which may simultaneously disconnect the alerting device and connects the audio circuitry to the line. This, in turn, draws direct current through the line, confirming that the called phone is now active. The exchange circuitry turns off the ring signal, and both telephones are now active and connected through the exchange. The parties may now converse as long as both phones remain off hook. When a party hangs up, placing the handset back on the cradle or hook, direct current ceases in that line, signaling the exchange to disconnect the call. Calls to parties beyond the local exchange are carried over trunk lines which establish connections between exchanges. In modern telephone networks, fiber optic cable and digital technology are often employed in such connections. Satellite technology may be used for communication over very long distances. In most landline telephones, the transmitter and receiver are located in the handset, although in a speakerphone these components may be located in the base or in a separate enclosure, powered by the line. The microphone produces a modulated electric current which varies its frequency and amplitude in response to the sound waves arriving at its diaphragm. The resulting current is transmitted along the telephone line to the local exchange, then on to the other phone, where it passes through the coil of the receiver. The varying current in the coil produces a corresponding movement of the receiver's diaphragm, reproducing the original sound waves present at the transmitter, along with the microphone and speaker. Additional circuitry is incorporated to prevent the incoming speaker signal and the outgoing microphone signal from interfering with each other. This is accomplished through a hybrid coil. The incoming audio signal passes through a resistor and the primary winding of the coil which passes it to the speaker. Since the current path A8A3 has a far lower impedance than the microphone, virtually all of the incoming signal passes through it and bypasses the microphone. The DC current through the resistor coil branch has no effect on the incoming audio signal, but the DC current passing through the microphone is turned into AC current, which then passes through only the upper branch of the coil's primary winding, which has far fewer turns than the lower primary winding. Alignment handset is a telephone designed for testing the telephone network, and may be attached directly to aerial lines and other infrastructure components.